And I just had a question. If evolution is such a rock-solid explanation for life on this planet, then what are they afraid of?
Yes.
Let all the theories be heard, and may the fittest theory survive.
That is a profound statement. In fact, Professor, would you read that again? That's a profound statement we need to communicate to this audience.
The rhetorical question is, if evolution is so airtight, such a rock-solid theory, then what are you afraid of? Why not allow other theories to come?
Certainly.
And you should feel confident. You know, if yours is so overarching and so readily able to explain every facet of life, then you would welcome all comers, I would think.
Yes.
So I attended this conference and took profuse notes of the Intelligent Design Conference by the Discovery Institute, and found out that planet Earth is very, very special.
Let's hear what you have to say.
Well, there's over a dozen features of planet Earth that make it incredibly
This is
different.
going to be overwhelming.
For one, the Earth is within the galactic habitable zone, the GHZ for short. It's in the middle between the spiral arms of Perseus and Sagittarius, and were it not in a place like that, we would not even be able to observe stellar space or the stellar heavens from our location. It would be like on Venus with that vapor canopy around it. They don't know what's out there. If there was any life there, they can't even see through the ceiling of the planet. And so, well, that's an interesting feature I never even thought of. Number two, the Earth orbits the perfect type of star, a main sequence G2 dwarf, which is not too large or too hot. Now, you'll notice this new planet's sun glows like a faint ember, it said. So I'm not sure if it's going to have the properties that are going to support life. It's certainly a different type of sun than what ours is.
Yes.
Number three, point brought out in the conference, is Earth has the right neighbors. It's protected by gas giant planets such as Jupiter and Saturn. And I thought, well, what difference would that make, until they pointed out, and I should have realized, they have enormous masses. Consequently, they have a large gravitational pull on deleterious bodies that come into the solar system.
To sweep the debris.
Exactly.
So it won't fall into us.
They're essentially like magnets that are pulling particles toward them.
Isn't that marvelous?
And so God thinks of everything.
It seems like this is designed, doesn't it?
It does. He couldn't just put us there, or he didn't, without the right neighbors.
Yes. Beautiful.
And so that takes care of that. And then number four, Earth is within the circumstellar habitable zone, the CHZ, between Venus and Mars. And like in real estate, it's location. And it's called the Goldilocks zone. Just right. Not too hot, not too cold.
Nice. Very nice.
We can have water in liquid form.
Beautiful.
Mars is just way too cold, and Venus is way too hot, has a runaway greenhouse and such.
Well, that is a beautiful concept, and truthfully so. Circumstellar habitable zone, that's beautiful, between Venus and Mars. All right, Professor. Go ahead, please.
For example, if Earth was just 5% closer to the sun, that's not very much. Yet the temperatures would be about 900 degrees Fahrenheit. And we think summers are hot now, but what it would cause is a runaway greenhouse effect.
Yes.
And if Earth was 20% farther away, it would be an ice planet, and you would find no liquid water.
So it's just right in its habitation.
And it's well to remember that water is the basis of every system that we have.
Yes.
The circulatory system, the respiratory system, the digestive system, and so on.
Our eyes are 90% water,
exactly,
etc.
So we've got to have water in liquid form. And so the question comes to mind, why all the fuss about finding water as scientists search for life in space? Well, we alluded to it already. The answer is that complex life is carbon-based. Water is essential for complex carbon-based life, and water is liquid over the same narrow temperature range where carbon chemistry is the most active.
That is a profound statement, and that made by Dr. J. Richards of the Discovery Institute.
He was the first speaker that
well, you have piqued my interest. Let's go beyond that. Time is marching because, again, we're having fun, and it is appearing already. It's apparently obvious to me, certainly, and hopefully to this audience, that planet Earth is very special. Take it from there.
Well, number 5 in my notes is that Earth has a nearly circular orbit. Its eccentricity, which is a term for how oblong the elliptical orbit is nearly zero. And this reduces the temperature fluctuation because we're not so terribly far away from the sun at any one point, and not so terribly close. And in my field of mathematics, we calculate eccentricity of elliptical bodies, and it's a ratio between the center of the ellipse, the distance from that point to the focus, versus the center of the ellipse to the end of the major axis. And that ratio, if it approaches 1, it's very oblong, and the closer it is to 0, the more circular it is. And so that really did appeal to me. I don't know how many other people in the audience that resonated with, but because of my field, that was a big deal.
I like it.
And so it's an important feature of this planet. Number 6, Earth has an oxygen-rich atmosphere.
Obviously.
This atmosphere is only about 1% of the Earth's total diameter of 8,000 miles, roughly, just under. And it's the only planet in our solar system with a transparent gas atmosphere. Enormously important feature due to the small amount of carbon in that atmosphere.
Yes, and I'm sure some in the audience with a medical background will appreciate Earth has an oxygen-rich atmosphere, but not an overload of oxygen. Not an overload of oxygen from the standpoint of volatility, so that a lightning strike won't cause the atmosphere to burst into an explosive flame. And at the same time, if we had a lot more oxygen in the atmosphere, not only the volatility is a problem, but the toxicity for living systems such as man and other mammals would be a problem. We get too much oxygen. So it's just right. It appears to me like it's been designed.
Exactly. Number 7, the Earth has just the right mass. If it was smaller, the CHZ, remember that's the circumstellar habitable zone, would be smaller. So the Earth would have to be closer to the sun. And the closer it is, the greater the gravitational attraction that the sun exerts on the Earth. So it would actually stop our relatively slow rotation. You know, we just rotate once every 24 hours, so we go about half as fast as an hour hand on a clock. But it would stop that rotation, and would that side would always be on the sunny side. And get way too hot, and the shadow side would be way too cold. Number 8, Earth is orbited by one large moon. You know, Jupiter has a number of moons and so on, but the moon is 1/4 the size of the Earth, and its gravity helps stabilize the Earth's axis tilt. And the fact that it is tilted about 23.5 degrees to the plane of the orbit, the rotation, doubles the amount of arable land. We have twice the amount of land surface that'll grow crops. You know,
that's
that is
beautiful.
The right temperature.
Plus it washes the ocean, cleanses the ocean.
A lot of beneficial effects. Number 9, the Earth has a strong, or an adequately strong magnetic field. Of course, we know it's declining. Generated by a circulating liquid iron core. This field helps to shield us from gamma rays, X-rays, ultraviolet rays.
Very important.
Other bombardments. Number 10, Earth's plate tectonics are just right. I hadn't thought much about that until the conference. The crust ranges from 4 miles to 30 miles thick, and is divided among over a dozen separate plates. The liquid iron core recycles carbon and regulates the internal temperature. So again, we're warmed from inside out, essentially. Number 11, on the features of the Earth that make it very special, the Earth's ratio of water to land. I used to wonder about that. Lord, did you not get that backwards? Should we be 70% land and 30% water? The answer is no.
No.
He had it just right.
Yes, always he does it just right.
And water is such a good thermal buffer. As evidenced by the fact that anywhere on Earth, we normally don't fluctuate more than about 25 degrees in any one day from the heat, the peak heat of the day and the lowest cold of the night. You know, so in the summer here, 95, and in the evening, maybe 75. So about 20 degrees, 25 degrees, and it makes life possible. The number 12, Earth is a terrestrial planet. Well, you might think, the audience may think, well, aren't they all? No, they're not. A number of them are gas planets. But life must have a terrestrial planet, not a gas planet. Of the 100+ planets detected, most all of them are gas giants and not terrestrial planets.
That's correct. We have a soil surface and rock surface.
Number 13, Earth has a moderate rate of rotation, once every 24 hours. Just right for the circadian rhythms is what I thought of, you know, in the conference, the cycles of life systems. Number 14, Earth, Sun, and Moon ratio is perfect. The Sun is 400 times bigger than the Moon. but the sun is also 400 times farther away.
Isn't that nice?
And that is really not accidental.